All right, let's go ahead and do some practice problems where we're balancing chemical equations. And so what we're going to do is we're going to take each of these chemical equations and we're going to balance them. Now notice how there's one that doesn't give us the chemical equation and the formula equation, but it gives us the word equation. And so what we need to do is write a chemical equation and then balance it. All right, so let's go ahead and get started with this. This right here, the way that you want to go about balancing is you just kind of want to start with maybe the first element, aluminum. There's one aluminum here, there's one aluminum there. And so we want to have the same amount of each atom on each side. And so that actually is balanced because there's one on each side. However, take a look at this. This right here has 3 bromines and there's 1 bromine here. Now the only thing we can do is we can put coefficients in the front of the entire formula that multiplies it to give us the correct number. So all we can do is put a large number in the front of the entire formula that multiplies everything it's in front of. And so again, there's 1 here, there's 3 here, so what do we need to put here to multiply it to give us 3? We need to put a 3 here. If we put a 3 here, that gives us 3 bromines. Now, when you put a 3 there, though, it doesn't only multiply the bromines, it also multiplies the potassium. The potassium, if you take a look, there's now 3 potassiums over here, and so what you need to do is put a 3 there to balance the potassiums. And then it's balanced. But what about here? And what about here? Well, if it's balanced and there's nothing there, it's assumed that there's a 1. And so you might see a question on a quest or an exam or something that asks you, what does the sum of the coefficients add up to? And I want you to pause the video and I really want you to think about this. We wrote the coefficients there to balance the chemical equation. What would the sum of the coefficients be? If you think it's 6, it's not correct. Because, again, yes, there's 3 and 3 here. That adds up to 6. But what about here? What is here? There is a 1 here. And what is here? There's a 1 there. And so really, because there are 1s here, this doesn't add up to 6, it adds up to 8. And so if you see a question where it asks you to add the sum of the coefficients, you need to make sure you also are adding the 1s that you're not writing. Now, this happens to be a single replacement. And the reason why it's a single replacement is because we have one thing alone by itself, and it's replacing another thing, which then becomes alone by itself. All right, so let's go ahead and do number 2 here. So this one we have to write a word equation. I'm sorry, we have to write a chemical equation from the word equation there. So it says we have solid aluminum. Okay, so we're starting with solid aluminum. And is mixed with aqueous lead 2 nitrate. Now, aqueous means dissolved in water. So it's aluminum plus lead 2. Now, lead 2, if you look on your periodic table, it's one of those ones we don't really know the charge of, but it's telling us the charge right there. It is a 2 plus. Now, nitrate is a polyatomic ion because it ends in 8, so it's a polyatomic ion. So you have to look at your polyatomic ion sheet, which is a 1 minus. And if you look at your polyatomic ion sheet, you see it's a 1 minus. Now, to balance that, you need 2 nitrates for every 1 lead. And this is what we learned last semester, coming up with the formula. And again, we learned this last semester talking about how we come up with the formula of different compounds. And so lead is Pb. Now, how do we show that there's 2 nitrates? Because what is nitrate again? Nitrate is NO3, so we have to include the 3 there because nitrate is NO3. But there's 2 of them, so we put it in parentheses and put a 2 on the outside. Now, what you do, put a yield sign, and it says solid lead is produced. Oh, we also forgot to put aqueous here. So it says solid lead is produced. And aqueous aluminum nitrate. Now, aluminum is a 3 plus. Again, nitrate is a 1 minus. So to balance that, you need 3 nitrates in this situation. Now there's our chemical equation, but it's unbalanced. And so this is our unbalanced chemical equation. So let's go ahead and balance it. Right now the aluminums are balanced, the leads are balanced. However, the nitrates are not balanced. There's 2 nitrates on the left, and there's 3 nitrates on the right. And so again, when it comes to polyatomic ions, we can treat polyatomic ions as a single unit. We can treat this entire thing as one unit. There's 2 of them on the left, there's 3 of them on the right. And so to balance that, what can the 2 and the 3 become? Well, the 2 and the 3 can both become 6. And so we put a 3 here and a 2 here. And when you do that, that actually balances the nitrates. And again, many times when you balance things, it will make other things unbalanced, and that's okay. It's okay that that happens because you can go back and balance it. Because look, there's 2 aluminums here now. So all we need to do is put a 2 here. There's 3 leads here. So all we need to do is put a 3 here. And that's it. And that's how you balance it. All right, let's go ahead and go on to the next one here. Oh, by the way, I forgot to put AQ here. Aqueous. Oh, and we also forgot to classify this. This also is a single replacement because there's one thing alone by itself and it comes in and replaces another. All right, this one. All right, this is a single replacement. Now, when you're looking at this, the sodium here, the sodium is going to come in and replace one of those. Now, how do you know which one it's going to replace? What I will say is metals will replace metals. Non-metals will replace non-metals, and that makes a lot of sense because if sodium, which becomes a positive cation, replaces the bromine, it will be paired with the positive cation. So if it ends up being like this, where and this is not correct, so I'm gonna write the incorrect thing. If bromine ends up alone by itself, which by the way is a hop wrinkle, and we end up with Na, I guess it would be FeNa3. This cannot happen because iron in this situation is a 3 positive. Sodium is a 1 positive. And a positive and a positive will not come together. They will actually repel each other. So this is not what happens. So here's how you remember it. Metals replace metals. Non-metals replace non-metals. All right, so let's go ahead and do this. Because sodium's coming in here and replacing iron, iron ends up alone by itself. And then the sodium ends up with the bromine. Now, when we are doing this, we need to think about the charges they make and balance the charges. Sodium is a 1 positive. Bromine is a 1 negative. And we get this from looking at the periodic table. And so this is a 1-to-1 ratio. You just need 1 of each. And so these are the correct formulas. So once we figure out the correct formulas, we can then balance it. So again, the key thing is to always make sure you have the correct formulas. Now, if you take a look, the bromines are unbalanced. So to balance that, you put a 3 right here. And when you do that, you then have to put a 3 here to balance the sodiums because there's 3 sodiums here. Now there's 3 sodiums there. And the irons happen to be balanced, so we're good with that. All right, this next one, combustion. What are always the products of a combustion reaction? It's always going to be carbon dioxide and water. Now, do you have to write carbon dioxide first? No. Do you have to write water first? No. It doesn't matter. It doesn't matter which one you write first, but those are going to be the 2 products in a combustion reaction for this class anyways. All right, so let's go ahead and go and balance this. Now, whenever you're balancing, especially combustion reactions, you want to save oxygen for last. Okay, so we have 2 carbons, and then we have 1 carbon on the right. So we need to put a 2 here to balance the carbons. Now, for the hydrogen, you need to put a 2 here to balance the hydrogen. Now, what I want you to do is I want you to answer this question. How many oxygens are on the left and how many oxygens are on the right? And so I want you to answer this question. Very important that you pause the video and answer this question, because this is the biggest mistake that people make. Pause the video and answer this question. How many oxygens are on the left side? In other words, how many oxygens are in the reactant side and how many oxygens are in the product side? So on this side, there's going to be 4 oxygens. And on the right side, there's going to be 6 oxygens. And the reason why that is because on the left, there's 2 oxygens here and there's 2 oxygens here. That's how we get this 4. And then on the right, there's 2 oxygens here and there's 4 oxygens here, which is how we get the 6. And so what you really need to recognize is that oxygen occurs in 2 different places. And so we know that we have 4 over here. We know we have 6 over here. So how do we balance that? We balance that by putting a 2 right here. I know there's going to be some people that might want to put a 3 there. But again, if you put a 3 there, that actually would end up giving us 8, because we have to remember that there's the 2 oxygens there as well. And so what ends up happening is now we have 6 over here, because we have 4 right here and 2 right there to give us 6. And that's it. The more practice you have with balancing, the easier it becomes. What I will say is one of the hardest parts of this unit is probably predicting the products. We'll have a lot more practice with this, but make sure that you're able to predict the products. But again, that's something that once you get more familiar with it, it's going to get really easy. Hope you have a great day, and see you in class.